If you are given data on how much force it takes to break a piece of wood with dimensions 4 by 4 by x when applied down the center, you will likely have a fair amount of data whose points are not all the same. What I mean by that is if at a span of 10 feet it takes 300 pounds to break the 4 by 4 by 10 in one test, in another test with the same length it might break at 295. While these numbers are very close, they are not the same. Run the test again, it breaks at 310. Because our specific type of wood is cut from trees that don't all grow uniformly, their breaking points are similar but not the same. Now that we have our data, how can we use it to make predictions? If we plot the data, it looks a lot like a linear line that has a negative slope. It makes sense. The wider the span to be covered, the less force our wood can withstand. As you can see, at each length x, the force it took to break the wood y is not the same for all points. But there is a pattern. We could simply draw a line like I did, but our goal here is to be precise. Our goal is to be able to use this in a more complicated scenario, so that if we wanted to, we could take a random length between our measured parameters and say with a reasonable amount of confidence it will break at this point. Or we could take a random breaking point, again within our parameters, and say it will break at these lengths. On this slide is a picture of equations we can use to estimate our parameters taken from our book Devore. If you start from left to right of the formula, we will first find our b hat 1, y-intercept. With b hat 1, we can then use it to find our next parameter, b hat naught, the slope. From here, we can find our variance after calculating our SEE. I use and see the word hat like I do a regular hat in real life. The hat changes the appearance of the person a little. Take the hat off and you still have the person. The person in this case is our population, and the hats are the data that we have for that population. What that hat looks like, conservative or ridiculous, will depend on our data gathering methods. Just like in any situation in statistics, garbage in, garbage out. We must make sure we have good data. So let's try to make sure we always buy good hats. Notice I always say within our parameters. In our book, the author talks about predicting data that is beyond the regression line parameters. In our example, we only did an analysis on spans between 4 to 10 feet. If we applied our formula, we could theoretically put any value for x or y, but since we do not have data that lie outside of 4 to 10 feet or corresponding downward forces, we cannot use our regression equation. As an example, if we were to make x a negative number, you would still be able to get a y force out of our equation, but that doesn't make sense, because a negative x value would give us a negative length. Not possible. On the other side, we could ask what length of wood could withstand a y force, and plug in a really large y value, and our x estimation would come out negative. Again, not possible.